low pressure gauge for pressure high and low.
Objectives. At the end of this video, you shall be able to test the high pressure gauge performance, test the low pressure gauge performance. Let us collect the tools and equipment required to do this exercise. Trainees Toolkit 1 set, Owner's Repair Manual 1 number, Manifold Gauges 1 number, Recovery Vacuum Pump, Car with AC, Cotton waste as required, soap oil as required, refrigerant. Procedure. Checking of refrigeration system with manifold high or low pressure gauge. Read the manifold gauge pressure with the following established conditions. Note: it should be noted that the gauge indications may vary slightly due to ambient temperature conditions. Normally functions refrigeration system. Low pressure side 1.5 to 2 kg or centimeter square, 21 to 28 psi, 147 to 196 kPa. High pressure side 14.5 to 15 kg by centimeter square, 206 to 213 psi, 1422 to 1471 kPa. Normal operating pressure ranges of car AC using HFC 134 at an ambient conditions of 32 degrees Celsius to 35 degrees Celsius are low pressure side 1 to 3 kg by centimeter square. B. High pressure side 12 to 22 kg by centimeter square. Step: clamp the gauge manifold of testing station to observe pressure conditions of car AC system. Connect low side and high side hoses to service ports of a car AC system. Start the car and switch on AC. Accelerate the engine shaft gear in neutral. The RPM of the engine or compressor shaft should be around 2600 for about 15 to 20 minutes. If the high side of car AC system is higher than normal, check for dirty condenser, clean the condenser. Air in the system condenser, recover and recharge the refrigerant. Excess refrigerant charge, purge out and reduce the refrigerant and check for normal cabinet temperature conditions. If high side of car AC system is lower than normal, check for leakage of refrigerant. Use soap solution to defect the leakage points of all fitting joints. If any leakage point is observed with soap bubbles, tighten the flare fitting joint. If there is no leakage, check for undercharge of refrigerant. In such case, the low pressure side gauge reads lower than normal. If the low side of car AC system is lower than normal, check for leakage points, arrest the leakage and reprocess the system for refrigerant charging. If the compressor has poor pumping, check for performance of compressor. The system in car cabinet is either poor or no cooling effect. If the low side of car AC system is higher than normal, check for overcharge of refrigerant and the high side pressure also becomes higher than normal. If compressor has poor pumping, check the performance of compressor. Moisture functions refrigeration system. Symptoms seen in refrigeration system. During operation, pressure on low pressure side sometimes becomes a vacuum and sometimes normal. Probable cause. Moisture entered in refrigeration system, frees at expansion valve orifice and stops cycles, but normal state is restored after a time when the ice melts. Diagnosis: dryer in oversaturated state. Moisture in refrigeration system freezes at expansion valve orifice and blocks circulations of refrigerant. Remedy: replace receiver and dryer. Remove moisture in cycle through repeated vacuum purging method. Charge new refrigerant to proper amount. Insufficient refrigerant condition: periodically cools and then fills to cool. Symptoms seen in refrigeration system: pressure low on both low and high pressure sides. Bubbles seen in side glass. Insufficient cooling performance. Probable cause: gas leakage at some place in refrigeration system. Refrigeration system. Diagnosis: insufficient refrigeration in system. Refrigerant leaking. Remedy: Check with leak detector repair. Charge refrigerant to proper amount. Poor circulation of refrigerant. Condition: insufficient cooling. Symptoms seen in refrigeration system: pressure low on both low and high pressure sides. Frost on tubes from receiver to unit. Probable cause: refrigerant flow obstructed by dirt in receiver. Diagnosis: receiver clogged. Remedy: replace receiver. Refrigerant overcharge or insufficient cooling of condenser. Condition: does not cool sufficiently. Symptoms seen in system: pressure too high on both low and high pressure side. Probable cause: unable to develop sufficient performance due to excessive refrigerant in system. Condenser cooling insufficient. Diagnosis: excessive refrigerant in cycle refrigerant overcharged. Condenser cooling in sufficient condenser fins clogged or fan motor faulty. Remedy: clean condenser. Check fan motor operation. If 1 and 2 are in normal state, check amount of refrigerant. Note: vent out refrigerant through gauge manifold low pressure side by gradually opening. Expansion valve improperly mounted or heat sensing tube defective. Opens too wide. Condition: insufficient cooling. Symptoms seen in refrigeration system: pressure too high or both low and high pressure sides. Probable cause: trouble in expansion valve or heat sensing tube not installed correctly. Refrigerant flow out of adjustment. Diagnosis: excessive refrigerant in low pressure piping. Expansion valve open too wide. Remedy: check heat sensing tube installed condition. If 1 is normal, test expansion valve is unit form. Replace if defective. Air present in refrigeration system. Condition: does not cool down sufficient. Systems seen in refrigeration system: pressure too high on both low and high pressure side. Probable cause: air entered in refrigeration system. Diagnosis: air present refrigeration system. Insufficient vacuum purging. Remedy: replace receiver and dryer. Compressor oil to see if dirty or insufficient. Vacuum purge and charge new refrigerant. Refrigerant does not circulate. Condition: does not cool. Cools from to time in some cases. Symptoms seen in refrigeration system: vacuum indicated on low pressure side. Very low pressure indicated on high frost or dew seen on piping before and after receiver and dryer or expansion valve. Probable cause: refrigerant flow obstructed by moisture or dirt in refrigerant freezing or adhering to expansion valve orifice. Refrigerant flow obstructed by gas leakage from expansion valve heat sensing tube. Diagnosis: expansion valve orifice clogged. Refrigerant does not flow. Remedy: allow to stand for some time and then restart operation to determine if trouble is caused by moisture or dirt. If caused by moisture, refer to procedure step 2. If caused by dirt, remove expansion valve and clean off dirt by blowing with air. If unable to remove dirt, replace valve, vacuum purge and charge new refrigerant to proper amount. For gas leakage from heat sensing tube, replace expansion valve. Defective compression compressor. Condition: does not cool. Symptoms seen in refrigeration system: pressure too high or low pressure side. Pressure too low at high pressure side. Probable cause: internal leak in compressor. Diagnosis: compression defective, valve leaking or broken, sliding parts, piston, cylinder, gasket, connecting rod, etc. Remedy: replace compressor.
Recap. In this video, we have discussed how to test the high pressure gauge performance, test the low pressure gauge performance. I hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you for watching this video. Hello, I hope you are all excited for today's session. In this module, we are going to learn how to practice in straight driving on wide roads.
Objectives: at the end of this video, you shall be able to drive a vehicle on a straight road, shift the gears smoothly using double declutching and single declutching, apply the brakes effectively. Let us collect the tools and equipment required to do this exercise. Tools, instruments required: trainee's tool kit 1 number, vehicle registration certificate 1 number, fitness certificate, driving license, L-boats, jack lever, equipment required, vehicle with stepney, materials required, cleaning cloth as required, soap oil as required. Driving a vehicle on a straight road refers to the operation and control of a motorized vehicle along a path where the curvature of the road remains constant, resulting in a linear trajectory without bends or turns. This straightforward motion involves maintaining the vehicle's alignment within the lanes or boundaries of the road while managing speed, acceleration, and braking to ensure safe and efficient travel. The driver's tasks typically include monitoring road conditions, adhering to traffic rules and signals, and making adjustments to steering and speed as needed to maintain a stable course along the straight path. Start the engine. Release the parking brake. Press the clutch pedal fully. Move the gear shifting lever into the first gear smoothly and retain your hands on the steering wheel. First gear is not synchromesh. Raise the engine speed a little and hold it there. This extra power is needed to move a stationary vehicle. See the rear view mirror for traffic coming from behind. Release the clutch pedal slowly till you feel the car is moving forward. Hold the clutch pedal. Look around over your right shoulder. Press the accelerator pedal further down gradually and simultaneously release the clutch pedal slowly. Allow the vehicle to move slowly. Keep both the hands on the steering wheel. Look ahead and lift the left foot off the clutch pedal. Let the car move steadily forward for a few yards. Shift the gear using either double T-clutching or single D-clutching smoothly. Hold the gear lever knob. Increase the car speed and then release the accelerator pedal. D-clutch fully just as the accelerator pedal comes up to the top. Shift the first gear to neutral. Engage the second gear. Increase the car speed by pressing the accelerator pedal. Repeat the above procedure for changing the gear from the second to the third. For changing the gear from third to second and second to first, repeat the same procedure. Prepare yourself for braking. Look into the rear view mirror and signal for stopping. Release the accelerator pedal gradually to avoid jerky movement. Apply the brake gradually. Just a little before the car stops, declutch. If it is not done properly, the engine will stop running. Stop the vehicle and put the gear shift lever to neutral position. Switch off the ignition. Apply the hand brake. Do not drive a vehicle at a speed more or less than what is specified by the manufacturer for a particular gear.
Recap. In this video, we have discussed how to drive a vehicle on a straight road, shift the gears smoothly using double declutching and single declutching. Apply the brakes effectively. I hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you.
Driving through lanes and curves.
Hello, my name is Marshall. I hope you are all excited for today's session. In this module, we are going to learn how to driving through lanes and curves.
Objectives. At the end of this video, you shall be able to drive through curves, drive through narrow lanes. Let us collect the tools and equipment required to do this exercise. Trainee's Toolkit 1 number, Vehicle Registration Certificate 1 number, Insurance Certificate, Fitness Certificate, Driving License, elbows, jack lever, vehicle with stepney, cleaning cloth as required, soap oil as required. Driving through lanes and curves involves the operation and control of a motorized vehicle along a road that includes bends, curves and multiple lanes. This type of driving requires the driver to navigate changes in direction, adjust speed, and position the vehicle within designated lanes or paths. Negotiating curves involves steering the vehicle smoothly and predictively to follow the curvature of the road while maintaining control and stability. Transitioning between lanes requires the driver to signal intentions, check blind spots, and merge safely into adjacent lanes. Successful driving through lanes and curves necessitates awareness of road's geometry, anticipation of upcoming changes, and skillful execution of steering, acceleration, and braking maneuvers to ensure safe and efficient travel. Task 1. Drive through curves, left turn at road junctions. See the rear view mirror for any vehicle coming behind. Show the signal to left either by the traffic indicator or by hand signaling. Move the vehicle to the left lane. Slow down the vehicle. Turn the vehicle to the left as shown in route A. Note, the vehicle should not be too close to the left side curb. Right turn at road junctions. See the rear view mirror for any vehicle coming from behind. Show the signal for turning to the right with the traffic indicator or by hand signaling. Slow down the vehicle and move to the right lane. Do not cross the center lines. Move the vehicle to the right as shown in route B. The driver should not move the vehicle as shown in route C. Route C is taken by some drivers against the law and is full of hazards. Turning right into a main road. Drive the vehicle width in your left half of the road as shown in the figure. Do not cut at the corners. Turning right into a side road. See if any car is coming opposite to you as shown in the figure. Shown in the indicator to turn right. Wait for the opposite traffic to clear. Slowly move the vehicle as shown in the figure. Cars coming from behind. A in figure. Permitted to overtake on the left side. Task 2. Drive through narrow lanes. Slow down the vehicle. See if any vehicle is coming in the opposite direction. Ensure that the lane is clear. Show the signal by switching on the headlamp. Slowly drive through the lane. While driving on narrow lanes, you should not overtake any vehicle and should always go in line one behind the other. Use of indicators correctly. Signal your intention well in advance so that the vehicle coming in front and from behind will be alert.
Recap. In this video, we have discussed how to drive through curves, drive through narrow lanes. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you. Hello, my name is Marshall. I hope you are all excited for today's session. In this module, we are going to learn how to drive a vehicle in reverse direction.
Objectives. At the end of this video, you shall be able to reverse the vehicle from the parking, reverse the vehicle when the vehicle is moving with traffic. Let us collect the tools and equipment required to do this exercise. Trainees Toolkit 1 number, Vehicle Registration Certificate 1 number, Fitness Certificate, Driving License, L-boats, Jack lever, Vehicle with stepney, Cleaning cloth as required, soap oil as required. Task 1. Reverse the vehicle from the parking. Reverse a vehicle from parking refers to the maneuver of moving a motorized vehicle backward from a stationary position within a designated parking space or area. This operation involves the driver shifting the transmission into reverse gear, which causes the vehicle to move backward. The driver must then use the steering wheel to guide the vehicle in the desired direction while also controlling the speed using the accelerator and brake pedals. During this maneuver, the driver must be attentive to the surroundings, including obstacles, pedestrians and other vehicles, using mirrors and turning their head to check blind spots. Safe reversing from parking requires precision in steering and speed control to navigate the vehicle out of the parking space and into the desired direction of travel, while also ensuring the safety of pedestrians and other road users. Step 1. While reverse the vehicle, ensure that there is nothing hidden behind the vehicle. Pedestrians, cyclists or other vehicles are not approaching you. The path is clear from all directions. Step 2. Get into the vehicle. Step 3. Start the vehicle. Step 4. Shift the gear in the reverse direction position. Step 5. See the rear view mirror. Step 6. Sound the horn. Step 7. Look back over your right or left shoulder. Step 8. Reverse the vehicle by slow acceleration and gradual operation of clutch. Task 2. Reversing the vehicle when driving on the road. Step 1. Give signal for stopping. Step 2. Slow down the speed. Step 3. Pull the vehicle as close to the left of the road as possible. Step 4. Look for any obstructions. Step 5. Stop the vehicle. Step 6. Shift the gear in the reverse position. Step 7. See the rear view mirror. Step 8. Look back over the right or left shoulder. Step 9. Sound the horn. Step 10. If the rear view is not clear, then take the help of others. Step 11. Reverse slowly to the desired location.
Recap. In this video, we have discussed how to reverse the vehicle from the parking. Reverse the vehicle when the vehicle is moving with traffic. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you for watching this video. Hello, I hope you are all excited for today's session. In this module, we are going to learn how to overtake another vehicle on road.
Objectives. At the end of this video, you shall be able to overtake another vehicle on road. Let us collect the tools and equipment required to do this exercise. Tools and instruments required. Trainee's toolkit, 1 number. Vehicle registration certificate, 1 number. Vehicle fitness certificate. Driving license, L-boats, jack lever, vehicle with stepney, materials required, cleaning cloth as required, soap oil as required, lube oil as required, coolant as required. Overtaking in the Indian driving system refers to the action of passing or moving ahead of another vehicle traveling in the same direction on a road. This maneuver typically involves moving into a lane beside the vehicle, being overtaken and accelerating to pass it safely. It's essential for drivers to follow specific rules and guidelines when overtaking to ensure safety on the road, such as ensuring there's enough space and visibility, using turn signals to indicate intentions, and yielding to oncoming traffic when necessary. Overtaking should be done with caution and only when it's safe to do so, respecting traffic laws and the safety of all road users. Task 1. Overtaking a vehicle. While overtaking a vehicle, looking at the rear view mirror and ensure that no vehicle behind you is too close. Give proper signal to the vehicle that you are overtaking. Sound the horn. Dim and dip at night. Never try to overtaking near an intersection, curves, any obstruction which makes the road not clearly visible. Ensure that there is enough road length before you without any oncoming vehicles. Maintain a safe distance from the vehicle moving in front. Change the gear down and accelerate to increase speed. Given maximum acceleration and overtake when a clear signal for overtaking is given by the vehicle, always overtake on the right side only. Maintain some distance from the vehicle you have overtaken and then move leftwards slowly. Recap. In this video, we have discussed how to overtake another vehicle on road. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you. Practice in driving through sand and wet surfaces. Practice in parking and diagonal parking.
Hello, my name is Marshall. I hope you are all excited for today's session. In this module, we are going to learn how to practice in driving through sand and wet surfaces. Practice in parking and diagonal parking.
Objectives. At the end of this video, you shall be able to drive a vehicle through sandy road, drive a vehicle on wet surface, park the vehicle on diagonally and parallel position. Let us collect the tools and equipment required to do this exercise. Tools, instruments required. Trainee's toolkit, 1 number. Vehicle registration certificate, 1 number. Insurance certificate. Fitness certificate. Driving license. L-boats. Jack lever. Equipment required. Vehicle with stepney. Materials required. Cleaning cloth as required. Soap oil as required. Sand driving. When driving through sand, maintain a steady speed to avoid getting stuck. Reduce tire pressure slightly to increase traction. Avoid sudden acceleration or braking, as thin can cause the vehicle to dig into the sand. Use a lower gear to maintain momentum and power through sandy patches. Steer gently and avoid sharp turns, as sand can cause the vehicle to slide. If stuck, try gently rocking the vehicle back and forth by alternating between forward and reverse gears. Wet surfaces. Reduce speed to prevent hydroplaning, which can occur when Tires lose contact with the road surface. Increase following distance from other vehicles for added safety. Use gentle, gradual movements when steering, braking and accelerating. Avoid sudden maneuvers that could lead to loss of control. Keep tires properly inflated for better grip on wet roads. If hydroplaning occurs, ease off the accelerator and steer in the direction you want to go. Parallel parking. Approach the parking space at a 45-degree angle, aligning your vehicle with the car in front. Reverse slowly while turning the steering wheel towards the curb. Once the front of your vehicle is in line with the rear bumper of the car in front, straighten the wheel and continue reversing. When the rear of your vehicle is near the curb, turn the wheel away from the curb to position the vehicle parallel to the curb. Adjust position as needed, leaving about a foot of space between your vehicle and the one in front. Perpendicular parking. Approach the parking space at a 90-degree angle. Align your vehicle with the parking space, ensuring you are not blocking traffic. Reverse slowly into the space, turning the wheel to guide the vehicle. Once the vehicle is centered in the space, straighten the wheel and continue reversing. Adjust position as needed, ensuring you are not too close to the vehicles on either side. Diagonal parking. Approach and positioning. Approach the diagonal parking space at a slight angle, allowing easier entry. Position your vehicle so it's parallel to the lines marking the space. Entering the space. Reverse slowly into the space, turning the wheel to follow the angle of the parking space. Continue reversing until the vehicle is properly aligned within the space. Adjustments. Check your position within the space and adjust as needed to ensure you are centered. Use mirrors and turn your head to check clearance with neighboring vehicles. Exiting the space. When leaving a diagonal parking space, slowly move forward, turning the wheel to align with the driving lane. Check for pedestrians and other vehicles before pulling out. Task 1. Driving a vehicle through sandy road. Do not accelerate much, otherwise the wheels will spin. Use the first or second gear and give sufficient acceleration. If the wheels begin to spin, declutch and switch off the engine, then use any of the techniques like chain on the wheels, etc. to bring the vehicle to the solid road surface. Task 2. Driving a vehicle on wet surface. Driving the vehicle very carefully. Use mud and snow thread tires to get more grip between the wheels and the surface. The speed must be 10 km per hour, as low as possible. Do not accelerate much. Switch on the highlights, the rear lights and the side lights. If you are crossing a causeway, ensure that the water level is below an exhaust pipe. If the rear wheel begins to spin, engage the front wheel drive and take out the vehicle from the sand using the first or second gear. Disengage the front wheel drive. The movement the vehicle comes on the solid surface. Task 3. Braking or stopping. Check for any vehicle in the rear view mirror. See if there is any vehicle behind your vehicle. Show the slowing down signal and slow down the vehicle. Press the brake pedal gradually, just a little before to stop the car declutch fully. If it is not done properly, the engine will stop running. Apply the brake and stop the vehicle. Put the gear in neutral, switch off the engine. Apply the handbrake. Recap.
In this video, we have discussed how to driving a vehicle through sandy road, driving a vehicle on wet surface, park the vehicle on diagonally and parallel position. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you.
Hello and welcome to this session. In this session, We will talk about logic operations and ICs used for digital circuit analysis and design.
Objectives. At the end of this session, you will be able to identify the basic logic gate ICs and their operations. Introduction to integrated circuits. The branch of electronics that deals with the research, development, and utilization of qualitatively new electronic devices is known as integrated microcircuits. This is the semiconductor-based chip which consists of set of digital circuitry. Integrated microcircuits, generally known as integrated circuits, are a low-cost electronic circuit consisting of active and passive components that are joined together on a single crystal chip of silicon. These interconnected components that make an IC are called integrated circuit elements. In digital ICs, information is represented by binary digits. TTL or transistor-transistor logic and CMOS, complementary metal oxide semiconductor, are two types of technologies used in the design and construction of integrated circuits or ICs, particularly in digital logic circuits. TTL devices are known for their speed and robustness. They typically operate on a power supply of 5 volts. CMOS circuits are highly valued for their low power consumption, especially when in a static or idle state. Logic gate. A logic gate is a device that acts as a building block for digital circuits. They perform basic logical functions that are fundamental to digital circuits. Most electronic devices we use today will have some form of logic gates in them. In a circuit, logic gates work based on a combination of digital signals coming from its inputs. Most logic gates have 2 inputs and 1 output, and they are based on Boolean algebra. At any given moment, every terminal is in one of the 2 binary conditions, true or false. False represents 0 and true represents 1. Depending on the type of logic gate being used and the combination of inputs, the binary output will differ. A logic gate can be thought of like a light switch, where in one position the output is off or 0, and in another it is on or 1. Logic gates are commonly used in integrated circuits. There are 3 types of logic gates: basic gates, OR, AND, and NOT gates, universal gates, NAND and NOR gates, derived gates, XOR gates, and XNOR gates. IC for AND logic gate. The AND gate performs the logical multiplication operation, which is commonly known as AND function. For 2 or more inputs, AND gate produces a high output only if all the inputs are high. It produces a low input even if one of the inputs is low. This is the symbol for the AND gate. The logical expression for an AND gate is Y is equal to A and B. For an AND gate with n inputs, there are 2 raised to n possible combinations of inputs. If n is equal to 2, there are 4 possible input combinations which are 0, 0, 0, 1, 1, 0 and 1, 1. The IC used for AND gate is IC7408. This IC includes 4 AND logic gates, where each gate is used separately without changing other gates. So it is called quadruple 2-input AND logic gates. This IC works with a single power supply, but it is available in several packages based on the circuit requirement. Now let's see the pin configuration of a 7408 integrated circuit. Pins 1 and 2 serve as inputs for the first AND gate. Pin 3 is the output for the first AND gate. Pins 4 and 5 act as inputs for the second AND gate. Pin 6 is the output for the second AND gate. Pins 9 and 10 are designated as inputs for the third AND gate. Pin 8 provides the output for the third AND gate. Pins 12 and 13 function as inputs for the fourth AND gate. Pin 11 is the output for the fourth AND gate. Pin 7 is connected to ground. Pin 14 is used for the supply voltage. Note that the supply voltage VCC for the 7408 IC is typically plus 5 volt. IC for OR logic gate. The gate which performs logical addition operation is known as OR gate, which is also known as OR function. For two or more inputs, the OR gate produces a high output only if one or all the inputs are high. It works similarly to the OR logic operation. This is the symbol for OR gate. The logical expression for an OR gate is Y is equal to A plus B. For an OR logic state IC, the number of input pins N determines the configuration. For an OR gate with N inputs, there are two N possible combinations of inputs, just like the AND gate. The IC used for OR gate is 7432. This IC includes 4 OR logic gates, where each gate is used separately without changing other gates. So it is called quadruple 2-input OR logic gates. Let's now see the pin configuration of IC 7432. Pin 1 and Pin 2 are inputs for the first OR gate, while Pin 3 is its output. Pin 4 and Pin 5 serve as inputs to the second OR gate, with Pin 6 as the output. For the third OR gate, Pin 10 and Pin 9 are the inputs, and Pin 8 is the output. The fourth OR gate uses Pin 12 and Pin 13 as inputs, and its output is on Pin 11. Pin 7 is connected to the ground. Pin 14 is the supply voltage or VCC, typically plus 5 volt. IC for NOT logic gate. The gate which performs inversion operation is called NOT gate. For a single input, NOT gate produces the output as a complement of the input. NOT gate produces a high output only if the input is low and a low output if the input is high. It works similarly to NOT logic operation. This is the symbol for NOT logic gate. The IC 7404 is a hex inverter chip, which means it contains 6 independent inverter gates. It typically comes in a 14-pin package. Let's see its pin configuration. Pin 1 and Pin 2 form the first inverter, with Pin 1 as the input and Pin 2 as the output. The second inverter consists of Pin 3 as the input and Pin 4 as the output. For the third inverter, Pin 5 is the input and Pin 6 is the output. The fourth inverter uses Pin 9 as the input and Pin 8 as the output. Pin 11 is the input and Pin 10 is the output for the fifth inverter. Finally, the sixth inverter comprises Pin 13 as the input and Pin 12 as the output. Pin 7 is connected to the ground. Pin 14 is connected to the supply voltage VCC, which is typically plus 5 volt.
This brings us to the end of this session. In this session, we have learned to identify basic logic ICs and their operations. Thank you for watching. We will see you in part 2 of this session. Hello and welcome to this session. In this session, we will discuss advanced logic ICs focusing on their logic functions. These ICs will serve as key elements in analyzing and designing digital circuits.
Objectives. At the end of this session, you will be able to identify the advanced logic gate ICs and their operations. Universal logic gates. Universal logic gates are a foundational concept in digital electronics. These gates are highly versatile and crucial because they have the unique ability to create any other type of logic gate or circuit. Here are some key features of universal logic gates. Versatility. The key feature of universal logic gates is their versatility. You can combine them in various ways to mimic the behavior of any other logic gate such as AND, OR, and NOT gates. This makes them extremely useful in designing complex digital circuits. Simplification of circuit design. Using universal logic gates simplifies the process of designing electronic circuits. Instead of needing a wide variety of different types of gates, a circuit designer can achieve the desired functionality using just one kind of universal logic gate. This uniformity can lead to easier manufacturing and potential cost savings. Efficiency in circuit construction. In practical terms, building a circuit with a single type of gate can be more efficient. It reduces the complexity in the layout and interconnection of different components on a circuit board. Educational and theoretical importance. In educational settings, universal logic gates are important for teaching the fundamentals of logic and circuit design. They demonstrate how various logical functions can be constructed and interrelated. There are two main types of universal logic gates, NAND and NOR gates. Integrated circuit for NAND logic gate. NAND gate is a combination of NOT gate and AND gate. In other words, NAND gate is an inversion of AND gate. It is called NAND as N stands for NOT, meaning a NOT AND gate. For two or more inputs, the NAND gate produces a high output only if one of the inputs is low. Here is the symbol for the NAND gate. The NAND gate Boolean expression is denoted by a complement of AND. Y is equal to AB bar. The IC used for NAND gate is IC7400. The IC7400 is a quad 2-input NAND gate chip, which means it contains 4 independent NAND gates. It comes in a standard 14-pin package. Here is the pin configuration of IC7400. Pins 1 and 2 are the inputs for the first NAND gate, with pin 3 as its output. The second NAND gate uses pin 4 and 5 as inputs, and its output is on pin 6. For the third NAND gate, pins 9 and 10 serve as inputs, while pin 8 is the output. The fourth NAND gate consists of pins 12 and 13 as inputs and pin 11 as the output. Pin 7 is connected to the ground. Pin 14 is connected to the supply voltage VCC, typically plus 5 volt. Integrated circuit for NOR logic operations. A NOR gate is the inversion of OR gate or a combination of NOT gate and OR gate. It is called NOR as N stands for NOT, meaning a NOT OR gate. For two or more inputs, the NOR gate produces a high output only if both inputs are low. Here is the symbol for the NOR gate. The NOR gate Boolean expression is denoted by a complement of R. It is expressed as Y is equal to A plus B bar. The IC used for NOR gate is IC7402. The IC7402 is a quad 2-input NOR gate chip, meaning it contains 4 independent NOR gates. It comes in a standard 14-pin package. Pins 2 and 3 are the inputs for the first NOR gate, and pin 1 is its output. The second NOR gate utilizes pins 5 and 6 as inputs, with pin 4 as the output. For the third NOR gate, pins 8 and 9 serve as inputs, and pin 10 is the output. The fourth NOR gate uses pins 11 and 12 as inputs, with pin 13 as its output. Pin 7 is the ground connection. Pin 14 is connected to the supply voltage VCC, typically plus 5 volt. Integrated circuit for XOR logic operations. XOR gate has 2 or more inputs but a single output. XOR gate generates a high output if both the inputs are not at the same logic level, A not equal to B. Here is the symbol. The IC used for XOR gate is IC7486. The IC7486 is a quad 2 input XOR gate. It contains 4 2-input XOR gates. It comes in a standard 14-pin package. Let's see the pin configuration for 7486 IC. Pins 1 and 2 are inputs for the first XOR gate, with pin 3 as its output. The second XOR gate uses pins 4 and 5 as inputs and pin 6 as the output. For the third XOR gate, pins 9 and 10 serve as inputs and pin 8 is the output. The fourth XOR gate has pins 12 and 13 as inputs, with pin 11 as its output. Pin 7 is connected to the ground. Pin 14 is connected to the supply voltage VCC, which is typically plus 5 volt. IC for XNOR gate. XNOR gate has 2 or more inputs but a single output. XNOR gate generates a high output if both the inputs are at the same logic level, A is equal to B. This is the symbol for XNOR gate. This is the Boolean expression for an XNOR gate, where this symbol represents the XOR operation and the overline represents the NOT operation. This means the output is the negation of the XOR of the inputs. The IC used for XNOR gate is IC74266. The IC74266 is a quad 2 input exclusive NOR or XNOR gate. This means it contains 4 XNOR gates inside a single IC package, and each gate has 2 inputs. Let's see the pin configuration. Pin 1 and pin 2. These are the inputs for the first XNOR gate. The output of this gate is taken at pin 3. Pin 5 and pin 6. These pins serve as inputs for the second XNOR gate with its output available at pin 4. Pin 8 and pin 9. These are the inputs for the third XNOR gate in the IC, and its output can be found at pin 10. Pin 12 and pin 13. They function as inputs to the fourth XNOR gate with the output provided at pin 11. Pin 7. This is the ground pin. It is connected to the negative side of the power supply. Pin 14. This is the VCC or power supply pin. It is connected to the positive side of the power supply, typically plus 5 volt for TTL ICs like the 74266.
This brings us to the end of this session. In this session, we have learned to identify advanced logic ICs and their operations. Thank you for joining us on this journey into the heart of digital systems. We will see you in the next session. Hello and welcome to this session. Today we are going to learn about a 4-to-1 multiplexer. This device is really important for choosing and sending data in systems like data compression and communication. Let us build and understand this key part and see how digital sections work.
Objectives. At the end of this session, you will be able to identify the tools and materials needed to construct and test 4-to-1 multiplexer circuit, and construct and test 4-to-1 multiplexer circuit using IC74LS153. Introduction to multiplexers. A multiplexer or MUX is a combinational logic circuit that channels one of several analog or digital input signals to a single output line based on the status of selector inputs. The power of a MUX lies in the control lines that decides which input line gets connected to the output at any given time. Based on the binary code applied to these selector pins, the associated data channel gets linked to the output. Looking closer at a 4x1 multiplexer, it consists of 4 data inputs labeled input 0 through input 3, 2 selector pins S0 and S1, and a single output. The status of S0 and S1 decides which input gets connected to the output at any point. We have 4 sample data inputs 010, 110, 001, and 101. Let's change the select inputs to 00. Notice the first data input 010 is directed to the output. Now we change select inputs to 10. So the second data input is transferred to the output. The multiplexer truth table clearly shows how each combination of S1 and S0 binary selectors activates a specific input route. This makes it easy to figure out the input-output status by looking at the selector bit state. Let's now look at the tools and materials to construct and test 4-to-1 multiplexer circuit using IC 74LS153. We will need the following tools and equipment. Digital trainer kit 1 number, digital multimeter with probes 1 number, wire stripper 1 number, tweezer 1 number. We will also require the following materials and components. IC 74LS153 and hookup wires as required. Let's now see the IC 74LS153 specifically designed as a dual 4-to-1 line data selector or multiplexer. The IC 74LS153 is a digital integrated circuit that belongs to the 74LS series. The 74LS153 is a dual 4-line to 1-line data selector or multiplexer. It consists of 2 individual 4-to-1 multiplexers within a single IC. Each multiplexer has 4 data input lines but only 1 output line. Let's look at the pin configuration of this IC. It comes in a 16-pin package. Pins 6, 5, 4 and 3 are the data inputs for the first multiplexer. Pins 10, 11, 12 and 13 are the data inputs for the second multiplexer. Pins 1 and 15 are the enable inputs for the first and second multiplexer respectively. These are active low inputs. Pins 14 and 2 are the select inputs for the first multiplexer and second multiplexer. Pin 8 is connected to ground (GND) and pin 16 is connected to the supply voltage (VCC). The outputs of the first and second multiplexers are pins 7 and 9 respectively. Let's now see the step-by-step procedure to construct and test a 4-to-1 multiplexer circuit using the 74LS153 integrated circuit. The first step is to gather all your components, laying them out neatly on your workspace. This includes 74LS153 IC. Since we are using a digital trainer kit, the major portions of the circuit like breadboard, power supply, switches, resistors and LED etc. are incorporated on that. Thoroughly inspect each part and verify you have the full set before beginning assembly. Once you have collected all the components, prepare the breadboard. Begin by inserting the 16-pin 74LS153 IC into the breadboard. Make sure all pins are properly aligned vertically and refer to the circuit diagram for accurate placement. Switch on the power supply to ensure plus 5 volt power supply section of digital IC trainer kit is working or not using a multimeter. Connect the power and ground of the trainer kit to the breadboard. Also take another jumper wire and connect one end of it to the plus 5 volt source and the other end with pin 16 as supply source. Connect one end of the first jumper wire to the ground rail or the ground source and the other end with pin 8. This step is essential for powering the IC and providing a common reference for the circuit. Make sure the enable pins of both the multiplexers, pin numbers 1 and 15, are in active low state. Make sure that the wires are firmly inserted into the breadboard and that the connections are not loose. Safety tip: a loose connection can lead to unstable circuit behavior. After making these connections, double-check against your circuit diagram to confirm that you have connected the pins correctly to the ground. Take 4 switches labeled as switches 1, 2, 3 and 4. Connect switch 1 to pin 6. Connect switch 2 to pin 5. Connect switch 3 to pin 4. Connect switch 4 to pin 3. Connect the selection input A with pin 14 and B with pin 2 through switches S5 and S6. The output of the first multiplexer is obtained at pin 7. Connect it to the output LED monitor. For the selection of inputs, adjust the toggle switches in the digital trainer kit to either in 5 volt or in 0 volt to represent the logic levels. Before powering up, double-check your circuit to prevent short circuits or incorrect connections. Once checked, turn on the 5 volt DC supply. You will use the switches connected to the data input pins S4 to S1 and the selection input pins S5, S6 for the first multiplexer and to test various combinations. Toggle the switches S6 and S5 to 0-0 combination. Output will be data input 0. If D0 is set to 0, the output Y should also be 0. If D0 is set to 1, the output Y should be 1. Toggle the switches S6 and S5 to the 0-1 combination. The output will be data input 1. If D1 is set to 0, the output Y should also be 0. If D1 is set to 1, the output Y should be 1. Toggle the switches S6 and S5 to the 1-0 combination. The output will be data input 2. If D2 is set to 0, the output Y should also be 0. If D2 is set to 1, the output Y should be 1. Toggle the switches S6 and S5 to the 1-1 combination. The output will be data input 3. If D3 is set to 0, the output Y should also be 0. If D3 is set to 1, the output Y should be 1.
This brings us to the end of this session. In this session, we have learned to identify the tools and materials needed to construct and test 4-to-1 multiplexer circuit and construction and testing of 4-to-1 multiplexer circuit using IC 74LS153. Thank you for watching. We'll see you in the next session.
Today I will be discussing on Civil Services Conduct Rules 1964. It is a very important and relevant topic. Every central government employee should be aware with these rules. The central civil services are concerned directly with the union non